Right, so we're going to look at conic sections. Conic sections are just cross sections of a cone. You take a cone, you slice a cone, you get different shapes. So in your booklet, we're going to skip over the first part of parabolas and come back to that second. We're going to do circles first because they're a little bit easier. But if I take a cone, and this is called a double napped cone, it has two cones on top of each other. They're connected at their vertex at that point there. And depending on how I slice the cone, I get different shapes for the cross section. So you can see this one that's kind of slanted here. This cross section forms a parabola. If I take a plane and I slice straight across that cone there, the cross section is going to be a circle. And if I do that same thing but kind of on a slant, it's going to form an ellipse. And if I take both of those cones and go straight up and down, perpendicular to the circular bases there, I get two little pieces here which kind of look like parabolas, two parabolas kind of facing away from each other, but it's not. It's called a hyperbola, and we'll see the difference between a parabola and a hyperbola. Hyperbolas actually have asymptotes, whereas parabolas don't. So that's what we're going to look at. It looks super confusing. If you page through your notes, we're going to circles to start. Okay, it comes right after the section on parabolas. So what we're going to look at is, so all of these conic sections can be formed. This is kind of a fun simulation to look at. Oh, maybe it doesn't. There we go. So circles we'll look at first, and circles are just the set of points in a plane that are the same distance from this fixed point, which we call the center. So we'll come back to, we'll look at ellipses, we'll look at parabolas in kind of a different way, and we'll look at these things called hyperbolas here in a few days. So let's look at the circles first, and this is kind of the beginning part of your notes, but this walks you through it pretty nicely. So I start with this fixed point called the center. I have this one point over here, coordinates are some x value, some y value, and the distance between those two is called r, which we'll call the radius. So if I collect all of the points, which is called a locus of points, that are the same distance from the center, it forms this circle. You can show that circle as a solid set of points there. And if I want to find the distance from any one of those points to the center, I would use my distance formula. So x minus my x coordinate, and usually that center, we usually call the coordinates for that h and k, or the coordinates for the center there. So if I find the distance, x minus your x coordinate for the center, which is h, and then y minus your y coordinate, which is the k value at the center there, and you square those values and take the square root, and that would give you that distance, which we've called r up here. And then usually they won't leave it as a square root equals that r, they'll square both sides. So this down here is called the general form for the equation of the circle, or standard form. So standard form for the equation of a circle, and the reason why they call that standard form is it's a nice way to look at an equation. You can see immediately what the center for the circle would be and what's the radius. So it would make it easy to graph if you knew those values there. So let's look at, well, we can put this on a graph, and we'll go through and we'll talk about, you know, if this is the center, it's over 3 and it's up 2. So over 3, this h value is 3, the y value is 2, and then the radius, the distance from the center to that point there, the radius is 4. There you go. So the radius squared would be 4 squared, which is 16. So let's look at a couple of problems right from your booklet then. So this is all the stuff we just talked about with the sketch pad. Standard form for the equation of the circle, where it comes from using the distance formula. So let's do a few of these. We won't do all these problems here, but we'll do a few of them. So the first one here, we're looking at coming up with the equation, standard form of the equation for the circle, and they give us the center and the radius. So x minus h squared, y minus k squared equals the radius squared. H and k are the coordinates for the center. So we'll leave the x and the y in the equation. If we subtract -4, it'll become +4. Y minus the k value, which is 1. And then the radius squared, 8 squared, would give us 64. And that's the equation for the circle. For part B, now they give you a center that's 0, 0. Same idea though, the center, if you do x minus 0 squared, well, you probably wouldn't write it that way, you probably just make it x squared. And same thing for the y minus 0 squared would just be y squared equals that radius squared. Okay, and then these examples are kind of the same idea. We'll just pick one or two of these out to do. Look at, let's do 44 because this one has a kind of weird number for the radius. So the center for that one is 0, 0. So the same idea as what we just did, x minus 0 squared, y minus 0 squared. And then we have to square the square root of 3, which is just 3. Right, the other ones are kind of the same thing that we've done before. Let's do, let's do 43. So if we put it in standard form, x minus negative 1 would be plus 1 squared. Y minus negative 4 would be plus 4, and radius squared would be 9. So that's the idea with those. You need to know the standard form for the equation so that you can plug those things in. You can work backwards. So like the next little batch there, they want us to find the center and the radius given the standard form for the equation. So again, we'll just pick one or two of these out. Let's look at 47 here. So the center for that one, there's no value added or subtracted from the x and the y in the parentheses like you have up here. So our center is just at the origin 0, 0, and the radius is the square root of 5. You can just leave it as square root of 5. And then, I don't know, how about, well, let's do 48. So the center for that would be the opposite of what you see inside the parentheses here, because remember the formula is a minus. So my h value would be 2, my y value would be negative 6, and the radius would be square root of 25, which is 5. Let's look at the next page. We won't do all of the problems. Do a little bit of sketching with these too. So on the next page there, the first example is the same thing that we just did. We're just going to go through and graph it. So let's find the center first. Will be positive 3 and negative 1. Radius is square root of 9, which is 3. And then to graph these, you plot your center. So 3, negative 1. And from that center, I'm going to do a radius of 3. So I'm going to go up 3, plot a point, down 3, left and right 3. And then just connect those with a nice smooth curve. That's a pretty fine looking circle there, by the way. I just saw you throw it in there. If your equation looks like this, you don't see parentheses anywhere in there. We want to put it in that form. We want it to look like this one here. So we need to complete the square for it. So the way you complete the square, we do this for all of the different shapes that we're going to look at. This is just circles, but we do the same thing for parabolas and ellipses and hyperbolas. So complete the square. So you're going to put the x terms together. It's just one x term. And then there's two y terms, a y squared and a 6y. And we'll put that constant on the right-hand side. So I kind of think of these things as being in parentheses here. Well, x squared is already a perfect square. You have no other x terms that you have to try and make it into a perfect square. So that can just stay the way it is there. But this y terms here, we have to complete the square for this. So to complete the square, you're going to look at that middle term's coefficient, which is 6. You don't have to worry about the plus or the minus yet. Half of 6 is 3, so you're going to add 3 squared, which is 9. So that's the value that's going to make that into a perfect square trinomial. So if I add 9 to the left side, I have to add 9 to the right side, otherwise the equation is no longer balanced. So once I have that, now I have a perfect square trinomial that's going to factor into the square root of this first term, which is y, the symbol from the middle term, which is a minus, and then the square root of this last term, which is 3, quantity squared. And then on the right-hand side, just combine your like terms together there and get 25. So for this one, our center, I don't have any value added or subtracted from x, so its h value would be 0. My k is positive 3. The radius would be 5. And same thing again. So plot the center, 0, 3. And then do a radius of 5. That's not such a pretty circle. That's okay though. So that's kind of the idea there with the graphing. So let's do another one where you have to complete the square there, because that's the trickiest part, but you will see that over and over again, so you'll get good at it. This one's a little bit hard to rewrite this. So x squared plus y squared, 8x minus 6y equals 0. So this one you have two x terms and you have two y terms, but we do the same thing. We'll put the x terms together. I'm going to leave a little space there to put my, the term that completes the square there. And we'll put the y squared terms together. And then we're ready to complete the square. So half of 8 is 4. 4 squared is 16. So since I added 16 to the left side, I'm going to add 16 to the right side. And then for y, half of the 6 is 3. 3 squared is 9. Since I added 9 to the left, I'm going to add 9 to the right. And now we can FOIL this and write this as a perfect square trinomial. So x plus 4, quantity squared, y symbol from the middle term, so minus 3 quantity squared equals 25. The center's opposite of the values that you see in here. So negative 4, positive 3, and the radius is 5. And again, you can go through and graph this thing here. Right, and if you don't have enough space on your graph there, just add lines on there. Radius of 5. What's that? 4. So you get the idea with the graphing there. Oh, that's a pretty bad circle, but you get the idea. All right, and then the last part is semicircles. And in calculus, a lot of times that's what we end up graphing. It's just part of a circle there, a semicircle, or even a quarter of a circle. So semicircles, you want to think of them as just being either the top half or the bottom half of your circle. So as you look at the equation there, if you have a positive square root, it's going to be the top half. If you have a negative square root, it's going to be the bottom half of the semicircle. So there's nothing really surprising, I would think, for that. So what I would do is I would first decide is it the top or the bottom half. So for this one, it's going to be the top half only since it's a positive square root there. And then you can get rid of the square root by squaring both sides. And then probably put this in standard form, put that x squared on the left-hand side with that y squared. My center then would be 0, 0, and the radius is 2. So to graph that, we'll start at 0, 0. Radius is 2. But remember, this is only the top half, so I don't need to go down 2 for this one here. So we'll just connect that top half. And don't connect the diameter because technically this is a function, this equation that we started with. If you connect, that diameter there, then it's no longer a function. So it's just the outside edge, the arc part of the circle that you're graphing. And then we can do the same thing for the second one here. So if you look at this, this is going to be, since it's a negative, it's going to be the bottom half only. And I would put the 3 on the other side here with the y to start. Just because the next step we want to square both sides to get rid of the root. And we want to leave this in this form, y minus 3 quantity squared, because that's part of the standard form for the equation of a circle. So we'll leave that as y minus 3 quantity squared. Don't multiply it out. On the right-hand side, the negative times the negative will be positive. So we'll just have 9 minus x squared. And then finally, standard form, the x squareds and the y squareds are all on the same side. Constant term by itself. So for this one, our center then would be at 0, 3 with a radius of 3. And again, we're only graphing the bottom half. So 0, 3 is my center. And then radius of 3. So it's going to look like that. Again, don't connect that diameter there. So that's it. That's all the stuff about circles. So the homework for circles is not in the textbook. It's the next page here. Both pages there, circle homework. A couple of graphs, a couple of semicircles on there, just those 10 problems there. And those solutions are posted online for you.